Okay, C3, differentiation, the product rule. Okay, why do we need the product rule? We use the product rule when we have a function y, or of course f of x, equals uv. And notice that u and v are timesing together. They are a product, okay? So if I want to differentiate something that's a product. Now this is the product rule. Look at it closely. dy by dx is v times the differential of the other one, so the differential of u, plus u times the differential of v. Okay, now that's the actual formula that we're going to use. That's known as the product rule. So that is the product rule. And if you want to know where it comes from, you can watch one of the videos on its proof. Okay, so I'm just going to show you how to use it. Okay, so the first thing I'm going to do is you can see that I've got a product. I've got x squared times 1 plus 2x. So I'm just going to randomly choose one of them as u and one of them as v. And it's pretty hard to get. You've got to make sure your u's and your v's look different. Okay, now this is how I set out my product rule. I draw myself a cross and I write in the top one my u, and then I write at the top of the next one my v. So 1 plus 2x, all right? You can get them the other way around, doesn't make any difference. Now, I'm going to use this cross a lot, and in fact I use it when we go on to C4 integration. So it's quite a good trick. So I'm always, when I go down, I am differentiating, and I'm going down the boxes. So what I'm going to do in here is I'm going to differentiate x squared. If I differentiate x squared, I'll get 2x, and then I'm going to go dv by dx, so I'm going to differentiate my v, and if I differentiate v, I get 2. Okay, so then what I'm going to do is I'm going to write out my product rule. My product rule says dy by dx is v du by dx plus u dv by dx, and I'm going to throw it all in. Okay, what is my v? Where's my v? There he is, 1 plus 2x, 1 plus 2x. My du by dx, there he is 2x. So he's going in as a 2x, plus u, so he's going down there, plus u, which is x squared, there's my u, and dv by dx is 2, so there goes in my 2. Okay, now often you can just leave it exactly like that. All right, because sometimes you're going to have to put numbers in, you just leave it like that. But occasionally it's worth neatening it up. Okay, how does it neaten up? So what I'm going to do is I'm going to think of it as two parts. So this is one part and this is a second part, and I'm going to factorise out as much as I can. So in this part I could factorise out a 2, and I could factorise out a 2 in that part, and I can also factorise out an x and an x. So watch carefully. I tend to use a big square bracket. So the first part, 2x times 1 plus 2x, that would give that first part, plus 2x times x would give the second part. And occasionally, so I suppose what we'd have to do then is with this big square bracket, let's actually neaten that up. 2x plus x is 3x, so we would have 2x big bracket 1 plus 3x. Now, you don't always have to do that, all right? You could actually just have stopped at that line, and I would only do that little factorising bit, this last little bit, if they told me to. Okay, next one. Okay, if you want to pause this video, why don't you pause it, have a little go, all right, and then you can see if you're right. Okay, here I go. So here comes my cross. I'm going to go u, I'm going to let him be u, and I'm going to let this one be v. So u is x plus 1 all squared, and v is 2x minus 1. Okay, we're going to differentiate, so we're going to go down. So dv by dx for this one, if I differentiate, is 2. And look how clever this is. Du by dx. Did you guys spot it? It's a chain rule. All right, I'm going to have to use the chain rule little trick to differentiate. So the 2 will come down in front, 2x plus 1 to the 1, and I'm going to times by the differential of the bracket, which is 1, which will give me 2x plus 1. Well done, guys. That was the chain rule. Okay, so here we go. dy by dx equals start that again. dy by dx equals v du by dx plus u dv by dx. All right, let's find it all. V, 2x minus 1. Du by dx is this one, 2 lots of x plus 1, plus u, which is this one, x plus 1 squared, times dv by dx, which is this one, which is 2. Okay, I would normally just completely leave it on that line, all right? But I'm just going to factorise it just in case you need it factorising. So we've got one bit here and one bit here. And in both of them, if I have a look at what I've got in both of them, I've got a 2 in both of them. Let's get rid of that. So I've got a 2 in both of them. And I've also got an x plus 1 in both of them. All right, so going into the first one, I will need 2x minus 1 plus, because I've got a plus there, and going into this one I will need another x plus 1. And if you're not happy with the factorising, just take a little bit of time to get that bit right. We're going to neaten up the big bracket, so 2x plus x is 3x, and minus 1 plus 1 minus 1 plus 1 is 0, isn't it? So I think it's that. And I suppose what I could do is neaten it up a little bit and say 3x times 2 is 6x. And so if they wanted it in a completely simple form, it's that. Okay, do you get it right? Brilliant. Let's go to the next one. Okay, so let's choose my u. That can be my u. This can be my v. Here comes my cross. U equals x squared and v equals cos 3x. Okay. So, come on pen, du by dx equals 2x and dv by dx. Okay, fantastic. It's a chain rule job or it's a little trick job. Okay, so cos 3x will be 3. Let's have a bit of a think. Sine differentiates to cos differentiates to minus sine, and it goes around like that. So cos differentiates to minus sine. So it's going to be minus 3 sine 3x. Okay, there we go, minus 3 sine 3x. Right, let's start off. So dy by dx equals v du by dx plus u dv by dx. Okay, where's my v? V is cos 3x, du by dx is 2x, plus u, so I've gone up here, x squared, dv by dx is there, minus 3 sine 3x. Okay. I would leave it like that, but if I had to factorise it further, there's actually not that much that can come out of this. In fact, there's only in this part and this part, there's only an x. So if they made me factorise, it's pretty useless, actually, the factorising. But if they made me factorise, it's going to go in like this. Big bracket, in the first part I would have 2 cos 3x plus, because it's a plus, and in the second part I would have x minus 3 sine 3x, which I suppose I should neaten up as 2 cos 3x, and then the minus 3 times the x will give me minus 3x sine 3x. Doesn't really look much neater, does it? But that's it, okay? Okay, now the question at the front says d by dx, doesn't it, over here? Now d by dx just means the differential of. So the differential of this gives us this. So if we differentiate this, we get this. Okay, so what we're going to do is, let's just rub that off. We're going to differentiate the first bit, all right, differentiate him and see if we can get him. So I'm going to let him be u and him be v because they're a product. Okay, so here comes my cross. U equals x plus 1 cubed and v equals 2x minus 1 to the 4. Okay, so u, du by dx it's a chain rule job. So 3 comes down, so it's going to be 3x plus 1 squared times the differential of the bracket, which is 1. So it's 3x plus 1 squared. And dv by dx is a chain rule again. So 4 comes down, 2x minus 1 cubed times the differential of the bracket, which is 2. So that gives us 8 2x minus 1 cubed. Okay, product rule. dy by dx equals u. Why do I always get that wrong? Let's start that again. dy by dx equals v du by dx plus u dv by dx. Okay, so the v, where's my v? The v is 2x minus 1 to the 4 times du by dx, which is 3x plus 1 squared, plus u, which is x plus 1 cubed, times dv by dx, which is 8 bracket 2x minus 1 cubed. Okay, now I would personally leave it like that, except the exam question is making me put it into this form. So can you notice in here, if we rub that out, notice that they want me to have some x plus 1 squared outside the bracket and 2x minus 1 cubed. So it's almost like they're giving me a bit of a hint, and this is my big square bracket. So I'm going to take their hint and I'm going to factorise out x plus 1 squared and 2x minus 1 cubed. So this is one part, this is second part, and here comes my big bracket. Now in the first part, I've got x plus 1 squared, I've got that bit. I've still got a 3 left, and 2x minus 1, well I've got 4 of them and I've got 3, so I'm going to need 2x minus 1, plus, because there's a plus, so let's take the second part. X plus 1 squared, I've got x plus 1 cubed, so I'm going to need x plus 1. I'm also going to need an 8, and 2x minus 1 cubed I've got. So that's what it looks like so far. Okay, x plus 1 squared, 2x minus 1 cubed. Let's neaten up this big bracket. So 6x minus 3 plus, times those out, 8x plus 8. Okay, can I make this a bit smaller? Give myself a bit of space. Come on, a bit of space. Okay, and then we're going to end up with x plus 1 squared, 2x minus 1 cubed, and the big bracket 6x, 8x is 14x, and 8 take away 3 is plus 5. There's my big bracket. So it asked me to find the values of a and b. So a is 14, there we go, and b, I don't know why I've put a bracket on that, and b is 5. Okay, done, perfect. Right, let's make him a bit smaller, move him up. The next thing it asked me to do was it asked me to find the coordinate of the stationary point. Now this is just not GCSE, is it? This is just C1, coordinate of the stationary point. Right, stationary point, we could do the bird. If you had a bit more space, you could do the bird, but you guys are probably happy now that the stationary point is when dy by dx equals 0. Okay, what's my dy by dx? This is my dy by dx, isn't it? That's my dy by dx. So it's when that equals 0. So x plus 1 squared, 2x minus 1 cubed, 14x plus 5, and therefore it equals 0 when either that bracket is 0, which means x must be minus 1, or that bracket is 0, which means x must be a half, or that bracket is 0, which must mean x is minus 5 over 14. Done.